everybody, and today we will be covering how to solve a simple stoichiometry problem. Stoichiometry is used in chemistry to find the amount of reactants or products of a chemical reaction, and we do that by using ratios and conversion factors. That definition sounds a little scary at first, but it's fairly simple. You could just think of it like a recipe. For example, if my chemical equation was actually a recipe where I'm using 1 cup of flour and 1 egg to make 1 serving of pasta, I could adjust that recipe to make a different amount of servings. Say I wanted to make 2 servings of pasta. I could then use 2 cups of flour and 2 eggs instead. We do this all by using ratios and following the chemical equations. Let's go to an example problem. In this first problem, we're asking how many moles of water are produced when you react 4 moles of O2 gas with 5 moles of H2 gas. What we always want to start by doing when we have a stoich problem is balance out the equation. So we will do this like so. Now we want to find the limiting reactant. The limiting reactant is what determines how much of the product can actually be made. Back to the recipe example. Say that 2 eggs and 1 pound of flour can make 1 cake. If we had 2 eggs and 3 pounds of flour, are we able to make more than 1 cake? No, we can still only make 1 cake. This is because our eggs are our limiting reactant. If we wanted to make more cake, we would need more eggs. So in chemistry, when we have multiple reactants, it's likely that one of them is limiting the reaction and how much product we can make. To find the limiting reactant, we want to look at the amount of reactants we are given. Here we see we have 4 moles of O2. What we want to do is go from moles of O2 to moles of water. We do this by using our molar ratios. We get our molar ratios by looking at our balanced equation. From the equation, we can see that for every 2 moles of H2O, we have 1 mole of oxygen. We can treat this like a unit conversion problem. So we want to cancel our moles of O2. So for the start of the equation, we put moles of O2 on the bottom. And for every 1 mole of O2, we have 2 moles of H2O, which we put at the top. We see that moles of O2 cancel out, leaving us with only moles of H2O as our unit. You multiply the 4 by 2, and you end up with 8 moles of H2O. But we're not done yet. We have to do the same thing with our H2 gas to see which is our limiting reactant. In the problem, we're given 5 moles of H2 gas. We're going to use our conversion factor from our equation. So for every 2 moles of H2, we also have 2 moles of H2O. Firstly, we want to cancel out our H2, so we put our 2 moles of H2 on the bottom. Then for every 2 moles of that, we have 2 moles of water, so we put the amount of water on top. We can see that our moles of H2 cancel, leaving us with just moles of water, and the 2's also cancel out, so that leaves us with 5 moles of H2O. So when we look at these, we see that we get 8 moles of H2O from the oxygen, but only 5 from the hydrogen. That means that hydrogen is our limiting reactant. No matter how much oxygen we use, the hydrogen is always going to limit us. The reactant that is not the limiting reactant is considered the excess, so we have excess oxygen here. Now that we found the limiting reactant, we can use that to find the moles of water. With hydrogen giving us 5 moles of H2O, that is the amount of water we can create. And that is how we solve a simple stoichiometry problem. Thank you so much for watching, and make sure to like and subscribe.